Yeah, so this stream is about constructing a quadratic Bezier, aka rotated parabola, that goes through P0, P1 and P gamma, such that the arc length is minimal, but at first I'm just going to construct it where the direction of the tangents in P gamma here is determined. And it seems that the arc length is minimal at the moment that the tangent is exactly the bisector of these two lines. So bisect line is like in the middle here, and then make that tangent something like this. That would be the also gives me the minimum arc length, but at first, I'm going to try to construct that thing. However, I'm having two useful vectors here, of course, because we want to bisect this. So I'm gonna have this vector here from P0 to P gamma. And, well, we have this vector here from P gamma to P1. Let's see, I have, what is this? Papers. Maybe I should just make a picture of it. Picture. I move this thing? It would be nice if you could move it, you know. Yeah. No idea if it is readable. Just made this picture. Didn't even completely made it. Oh, it's not a good picture. So, make a new picture. Okay. I need to zoom in. Nope, totally not. That works. Alt. Oh, no, we get that. Well, how about alt like this? Also not. That worked. So there we are. So you have point parameterized by t is the point for in the point at t is 0 plus v0 times t plus a half a0 t squared. That's the usable quadratic Bezier equation that I use. Yeah, where p0, v0, and a0 and np itself are two-dimensional vectors, and t is the parameter that we parameterize this thing with. And then we define p1, which is the point at t equals 1, so we just fill in t is 1. So p1 equals, well, that was t filled in to be 1. From this I can conclude that a0 can be written as 2 times p1 minus p0 minus v0. Just move these two to the other side and then times 2. And of course, while I'm working with the shape of the Bezier curve, so I'm really not interested in where it lives. Translation is not important, so we should work with the difference between p1 and p0. So let's just write it as q1. And then we can write a0 as 2 times q1 minus v0, because this is just q1. No, completely lost how I did the zoom. Oh. I guess I did that like that. Hey. Now, likewise, subtract p0 from pt here to get qt, to get rid of any translation. Which is, of course, just the last two, where I replace a0 with what we found here. Then we get qt is v0 times t plus q1 minus v0 times t squared. And then I have a third point, q beta. So you can the graph, the function here. We have a parabola, rotated parabola that goes through p0, p beta, and p1. Yep, and then q1 is the vector from p0 to p1, and q beta here is the vector from p0 to p beta. So yes, p beta is also known. I want to define q beta here. Q beta is p beta minus p0. Which is just the point at t equals beta. So I can fill that in. Fill in beta here, and then we get v0 times beta plus q1 minus v0 times beta squared, or we can also write it as v0 times beta minus beta squared plus q1 times beta squared. And from which is then equal to the q beta, right? Q beta was known, so now we can write v0 as well. So we got rid of a0, and now we get rid of v0. That is then q beta minus, so we'll bring this to the other side. Beta squared times q1 here, and then all divided by beta minus beta squared. I repeated that thing here, so I might as well go here. So now we're talking about the velocity, which is the first derivative of pt. And that is of course then v0 plus a0 times t. Here I repeat what v0 is, written a little bit different. Q beta divided by beta times 1 minus beta, minus beta divided by 1 minus beta times q1. So interestingly enough, this v0 points, oh sorry, this v0, yeah, we want to have a v beta. So we can fill that in, t equals beta, so v beta is v0 plus a0 times beta, t replaced with beta here. And then you can write that, fill in a0, which was 2 times q1 minus v0. And then separate v0 again. So we get v0 times 1 minus 2 beta plus 2 times beta times q1. And then solve, no, not solve, fill in v0. So this. And then you get in the end v beta is something, some function of beta times q beta plus some other function of beta times q1. So it is now expressed in this vector q beta and this vector. But really I wanted to express it in this vector and this vector, because in the end we're going to find that the minimal arc length is then v beta that is exactly in between those. Now suppose I have two vectors here and I want only talk about the direction. I'm not sure actually, but I doubt this is very interesting. I would like to talk about that. Could do so. So this, let's call this one, I don't know. It's P1 minus P beta. So I'm going to write that down on my paper. That thing should have a name though. I'm just going to call it S. So we have S, so we'll write let S is P1 minus P beta, which then equals P1 minus P0, of course, minus P beta minus P0. Just subtract P0 and add P0, which is equal to Q1 minus Q beta. And then I want to write this in terms of Q beta and Q1 minus Q beta rather, which I'm going to call S, yes. Or I guess I just have to add and subtract q beta times this. And then I can combine that with this one to get to something functional beta times s. And the other one, then combine that with this one. And write it out. Is this something more, something simpler? Maybe I should write that one out first. Looks like a second degree polynomial in beta. Yeah, okay, so that is 2 beta minus 2 beta squared minus beta plus 2 beta squared. Oh, really? The whole thing is equal to beta. This is beta, really? 2, yeah, 2 beta times minus beta is minus 2 beta squared, and here I have minus minus, so that's plus 2 beta squared. That drops away, and here we have 2 beta times a 1 minus 1 beta. Yeah, this thing is beta. Okay, so I have v beta equals 1 minus 2 beta divided by beta times 1 minus beta times q beta plus beta divided by 1 minus beta apparently times q1, and then I want to subtract that same factor times q beta, right? Yep. So I'm going to do minus beta divided by 1 minus beta q beta plus beta divided by 1 minus beta times q beta, and then these two combine into beta divided by 1 minus beta times s. I can make this a square and then divide it by beta, and then I can combine those two. So this is then a plus, I guess, divided by the beta times 1 minus beta. Then I have beta squared minus 2 beta plus 1 times q beta, which, if I'm not mistaken, is beta minus 1 squared. You got to be fucking kidding me. Yep, so that drops out. So that is then equal to one minus beta divided by beta times q beta plus beta divided by 1 minus beta times s. better. Yeah, let's draw that in. See if that makes any sense, or the small chance that I made a mistake, right? On the cube of Bezier. So this takes the V0 instead of V beta, but okay, I'm getting a gamma here. Gamma is beta, whatever. So once I get here, I can draw I want to draw a connector. So let's make a plot connector. Gonna have to call it comma. Mixing betas and commas. Why did I use beta here? Oh, just replace all the betas with comma. Oh, the chat was delayed. I suddenly get a whole page of chat. I'll be Manu hi, and Oom is back. Zes wants to see my face. Yeah, no. The US government now enforces Rust. Jesus Christ. The politicians have become completely crazy. Completely control. I'm not allowed to say this. They want to control what I think. Death to all politicians. C++ is the way forward. Really, the last thing we need, the humanity needs, is that the government is going to tell us what programming language we need to use. Have they become completely, utterly crazy? Okay, it has been decided. I will never use Rust. Ever. How does one create a connector? Of course, I need a second layer. And then some style. I guess a line style or something. I must have more of these things. A line style. I'm just going to use a line style. I think my line style is dashed, I think. Is it not? It's not. Well, curve line style is not. Let's use solid line style then. And then, yeah, just the constructor of the connector. From 2 point. Yeah, okay. 2 points from 2. That does not work. Or does it? Maybe it does work actually. No, it does not. If this is the velocity in this point, it should be tangent to it. Dude, it's not right. Something is wrong. Yeah, I don't know. Maybe I should not have started streaming. I just have to do some math on paper, pen and paper. And I think I made a mistake here because it doesn't work. Yeah, should fix this as well. Let's put the Bezier here, -6, -1. And we put that one there, there, -4, 1. That works. Yeah, I think this green point is what I just added. Yeah. So the gamma is correct. I want red instead of green. I don't know what that is, but let's try 3. It's at least not green anymore. Oh. I don't know what color that is, but it still looks green. What is going on? 4 now. Blue. No, yeah, blue is good. Blue is not green. Create points. That's Q. Yeah, I cannot not draw it because it's draggable. So the thing must exist. Yeah. Could use your lips. Draw this transparent column. Don't see how to do that without making changes. Why the hell does this thing not have a line width? Yeah, get it. Now what? Okay. It's an open circle, but if I move it here, there's a blue cross in it. I really want that to make red. But I don't know where the colors even come from anymore. Color table like this. Table, something with table. Black backgrounds. First one seemed red to me, but well, there will be 0. This is red. Totally red. Try this one. I don't know. 31 and 17. How much is 31 minus 17? $14. Yeah, that is red. Totally not red in my eyes. It's more black than anything else. This is so not working. I'm going to try everything until I find something that's red. Yes, totally red. Right, and then we'd have to do I could make it an ellipse as well and then solid. Okay, so the question is why this not the velocity? Because it totally is not, is it? Well, no, it's not. Let's draw the real velocity. Just so I want to find this formula, but for now we're going to use the actual velocity at. So that is bc dot v at comma. No, it's velocity, not v. But velocity. So this is the actual velocity. Yeah, now you see it's really tangent to the curve, isn't it? And also it goes from completely in the direction of P1 to completely parallel with the other one. And if I set it to the minimum length, 13,654, this is the minimum. Now it's bisecting these two, I think. Looks like it, yeah. Hey, Kotaro. The question. The question is, okay, so I have this vector from here to there, and I call that S. And I have this vector from P0 to that, which we could also draw starting here. And I want to express that one in terms of this one and that one. I'm not even sure if I want that though. But anyway, I thought that's what I did, and apparently I didn't. Guess I can draw S from here to there. And the other one as well, starting in P comma, to see if they are correctly calculated. Yes, well, of course they are. These two. But okay, why not? Two connectors. plot the Q comma and the S. From that to, and then here we do that vector S, just plus S. The other one is Q comma. Well, yeah. Oh, I'm glad you like the chats, man. Aha! Now that explains it. So this vector is correct, but this vector is not what I wanted. This vector should end in P1, so I just have the vector wrong. Oh, what an idiot. Yeah, that's this vector, clearly. So I was using the vector from P0 to P1 instead of this. It must be P1 minus P comma. So I did not make a mistake then, with mathematics anyway. Yeah, huh? What? S? What? I'm a complete idiot. S is, looking at my paper, P1 minus P beta. Okay, subtract P0, must be subtract comma. Yes, yes, it is correct. This is the velocity. At least it's tangent to. To be 100% sure, I might as well draw the velocity as well. The actual velocity. Yep, they're all on top of each other. Okay, let's kill that one again. Okay. Let me think. So as you can see that the velocity in p gamma is 1 minus gamma divided by gamma times q gamma, this is a vector, plus the opposite, gamma divided by 1 minus gamma times the other vector. And now I am only interested in the direction of it. So if I divide this by that, then I remove the length of V gamma. At least, yeah, whatever V gamma is, independent of the length. Saying this correctly? So suppose I have a certain velocity and I make the velocity twice as big. Well, the only way to do that is by multiplying this by 2 and that by 2. Then the direction doesn't change, but V gamma itself becomes twice as long. So the direction is completely captured by dividing this by that, or the other way around. Which is then the square of one of these. Let's pick this one. So that and then squared. Is a measure for the direction. And then of course the square is not necessary. Because, I mean, what... Yeah. So this thing alone is a measure for the direction already. In other words, having the direction allows me to calculate gamma, and from there everything else. So let's do that. Let's see, what do I need here to... What do I need to add here? Is that to me, Kotaro? Or is it to... Oh, you're just talking to each other. It was to me, I see. So, yeah, so this arrow here is the velocity in p gamma. That is, if you change t from 0 to 1, you walk over this curve. And then the speed that you walk at this point, or, I don't know, distance per change in t, is equal to this vector. So we go, of course, in the direction tangent to the curve. And I have expressed this vector in these two vectors. And it turns out that, let me see which one is which. Okay, so if I rotate it all the way here, then there's an enormous amount of curvature between P0 and P gamma. So gamma is almost 1. Yeah, because now it may be 0.999, and then when it's 1, it's here. Yeah. T is 0, T is 0.999, and then T is 1. Okay. Therefore, gamma itself is 0.999. Yeah, the gamma is the value of T in this point. And therefore, we have I think gamma divided by 1 minus gamma times this vector. So gamma is 1 divided by 1 minus, well, gamma is 0.999 divided by 1.999 is a very large vector times P1. So the velocity is over there somewhere. And this one is the opposite. This one is 1 minus 0.999 divided by 0.999, so that's almost nothing times this one. And here it's somewhere in between, so it could be, I don't know. I guess if gamma equals a half, then we have a half divided by 1 minus a half is 1. And 1 minus a half divided by half is also 1. So if gamma equals a half, then the velocity is exactly this vector plus that vector, which is what it is now. So here gamma is a half, I think. Now if I'm only interested in the direction of this velocity vector here, then the factor that I multiply this one with, in this case that is 1 times this vector plus 1 times this vector. I might as well do 2 times this vector plus 2 times that vector. Or x times this vector plus x times this vector. Yeah, you just move over this line then, in this direction. Therefore, the direction of this vector is determined by the ratio between the vectors, between these two. The most short-term target of what I'm doing now is to construct a quadratic, not a cubic, but a quadratic Bezier curve as function of with given P0, P gamma, P1, and the direction of the tangents at P gamma. So I don't have the velocity, I just have the direction in which it is going here. And that direction is completely determined by the ratio between these two, the vectors of these two vectors, which then happens to be gamma squared divided by 1 minus gamma squared, which in my opinion is the same as gamma divided by 1 minus gamma. Well, in the end it's the same as whatever gamma value is, but that's what I want to calculate. I think it's going to be a lot more clear. I'll just write a code, and you can see what I'm doing. I'm worse at explaining, I think, than at writing code. So I'm going to write a BezierCurve extra function quadratic from. So here I have one that is using P0. P0 and P1 are always given, the begin and end point of the Bezier curve. And then I'm using a third point, P gamma, and then the direction at P0. So now we're going to do exactly the same, but then in P gamma. Initialize quadratic Bezier curve from one more data point and the direction vector in P gamma. Where the hell do I get a gamma from here? Don't have a gamma here. I have a gamma somewhere, but not here. I probably have a gamma in here. Nope. I was working cubic. Yeah, Pico. So I know the direction in the point P gamma. That's what we know. Or the same as a tangent at that point. So I have to write that one. So this works for D0. And now I'm going to write one for that one. I don't like repeating myself, but what it has to do with Viking, I'm not sure. So first objective now is to calculate gamma, and then the rest follows, and the whole curve follows. And I have the direction d gamma. Therefore, I can use those other two vectors as a base Other two vectors being oh shit. Overload is not working this way. Yeah, how to solve that? Just combine it with this one. Let's call this D. And then we are passing. Gonna turn around. Call it X, and I'm gonna pass an int X. Where X is 0, 1, or 2. Oh my god, well, I don't know. No, that doesn't even work. Actually, maybe we should make it an enum then. I don't know, you meant explicit. Yes, for this one. I mean, that's the reason why I'm using vector. Like that. Dx, comma, point. What? Or vector? Yes, explicit one. Constructing from a point is explicit. I'd rather use a switch, maybe. We never get here. CW? AR. Never reached. The thing is so not ever reached that I don't even need a semicolon, I think. Yep, add semicolon here. Haha, just you know. Okay, so I probably need a P1 and a P0, why not, you know? I mean, I definitely need P1 and P0. Probably need a P1 P0 and a P gamma P0 maybe. Actually, I'm not sure, but why not? Then I do the switch, and then if you pass 0.0, then we do what it did, and otherwise we do this, which is then going to be the new function. And then I need my enum. Could be an enum inside the BezierCurve. Yeah, sorry, you want to see the point as well, huh? Well, point is really just point, X and Y coordinates. Sorry, I have to do the, what was I doing? Thinking, okay, I don't know anymore. So point here then. Cairo window pointer, this one. Cairo window point is just the double X and Y, obviously, which you can construct from it, from two doubles. And direction is Direction is also an xy, but in this case must be unit vector. So if you construct it from arbitrary points, then it just makes it a unit vector by dividing it by the length. Oh yeah, right, I was going to add point in t to the class. No, it's from 2 points. One point, 2 points. Or you mean this one? If only 1 point is given, then the direction is from the origin. And this is explicit. So yeah, sorry, you probably mean this one. You can construct it. I thought you was talking about the vector, but you can construct a direction from a single point as well. Yeah. And then it's just from the origin. And obviously that has to be explicit because it's just a weird thing to do. And this one is, even this one is explicit. This one is an angle in radians. It's not explicit. Yeah, let's make one of them default or not. Nah, not. Okay, so now everything stops compiling because I have to pass that, and I can only pass it if it is public. So you have to go back here and then make it public. And that's super annoying actually. Now it is a part of BezierCurve. Let's not do that. Let's just move it outside. And then of course make it more general, even though I'm not using them. No matching member function will call to quadratic from blah blah, which is because I swapped these two, and this must be then 0.0, isn't it? Yep. Actually it's not, because it's p gamma. Oh, it is v0 direction. No, wait, what? Oh yeah, right now it's constructed from The direction that I pass, it belongs to 0.0. So yeah, it is 0.0 at the moment. Can't print enum. What? Reference to non-static member function must be called. This is now dx. Holy moly. So many D zeros. dx, dx, and dxx. No, maybe x was not the best name. So you call dn, di maybe. Oh no, it looks like a... well, never mind. Happy Monday, okay man. Thanks for hanging out. Good night. Yeah, it's your bedtime around this time. Yeah, it is. Yeah, yes. Wow, man. Late. I'm sitting in the cold here. Something else in dark. Shall I turn on the heater? Why didn't I get cold earlier? Nia leaves and I'm suddenly feeling cold. I'm rich anyway. 20 degrees for the next let's heat up the house 3 degrees for the 2 hours that I'm still here. Shit, I forgot to bring my dinner back. Oh, actually I forgot to buy food. I'm such an idiot. I forget it. The plan was to buy food after I came back from chess. The shop was still open. So now I don't have breakfast for tomorrow. And I should have brought my dinner. So tomorrow I'm going to my dad again, but it's definitely the last time I eat there. So then after that I will only be with my dad in the afternoon, not in the evenings anymore. So then I can definitely stream at normal times again. But I have been eating breakfast and basically lunch, which I eat around 6 o'clock over there the whole week. So nothing in my house. If I did, I walked away. Okay, so now I want to express this thing in S and Q beta, which probably means that I first have to create those. Where Q beta happens to be where's my paper with my little graph? Q beta is just vector from P0 to P beta, right? And then of course gamma. So I'm using lots of papers. This is it. Yep. So then translated to gammas, that would be P gamma minus P0, which I already have. Oh, the other way around. Seriously? No. What? Arg. This is from 2, isn't it? The minus sign. Subtracting vectors. Doesn't even say 2 from. This. Oh, wait a minute. That's 2 vectors. These are 2 points, but it's a plus. I defined that one with point. Point minus 2 from. Yeah, so this points from gamma to P0. I don't want that. I want the other way around. In this case. And this one as well. Points to P0. Why the hell would I want that? This is highly annoying. Okay, let's just move them. Then we do that again, but now I'm gonna call it Q beta. Oops, which is then equal to 2 from. So 2 is then P beta. Well, gamma. Yeah, so the opposite of that one. Minus actually. Right, so I need to find A and B such that di is A times Q gamma plus B times S. How does one do that? I guess I need to take the dot product then with the Q gamma rotated 90 degrees. I take the dot product of this. No. Yeah. Pen and paper. Pen and paper is always a solution. Yeah, need to make the inverse of a matrix. But I think my matrix is two-dimensional, and that's kind of can be done without lip eigen, I guess. Okay, so this one was, I don't know, one of them was Q. I'm just going to call them V1 and V2 for the moment. Dx and dy. Ridiculous to talk about x and y. But okay. Yeah, vertically I get Q here. Or Q beta, or what the hell was it called? Yep, Q beta and S. Yep. And they are not orthogonal. They are what is it? They are not linear dependent, but they're also not orthogonal. Orthogonal. Or how the hell do you pronounce it? Change of bases. I don't know the change of bases. I don't have a basis at all. And now I want to find the coordinates relative to my new basis. Yeah, I don't think so. I mean, I have to take the inverse then first. Yeah, blah. They talk too much about x and y and to log it. And you have orthogonal bases here, which are also not very interesting. This picture looks like it is not orthogonal, but then again, it probably is. Maybe you should explicitly type in that they are not orthogonal. Brilliant. Yep. This is what I needed. That's good. So I just calculate all 3 dot products and can I copy that? Ja, dat dropped out B. Yeah, the eye is a direction. I can only take the dots with a vector, I think. Dots. Oh, this is a direction. Haha, direction dot exists. I can take the dot with another direction, but not with the vector. What the heck? The vector can only take it with another vector. Can convert the direction to a vector easily. And then take the dot product. Probably have to do this explicitly now. I'll turn it around now. I'll turn this one around. Di dot s okay, di dot gamma times the square. That's bullshit. S dot length squared minus di dot s times s dot gamma. Oh, I don't have that one yet. Okay, there's going to be s dot q gamma those are just two vectors. Divided by, that is q comma length squared, times s length squared minus the square of q comma s, or s dot q comma is the same thing. So now A is the vector of q gamma, right? And I had the formula that it is 1 minus beta d over beta. Well, 1 minus gamma over gamma. But that is the velocity. Which is derived on paper. So yeah, sorry about that. Just have this formula. We have A times Q gamma and B times S. So A times Q gamma. So we must, that's A. Divided by, let's put stuff around us. That. I probably need to calculate B as well then. I have the feeling that I can calculate A divided by B kind of directly. In other words, mil multiply. To multiply with that. Yeah, I guess it's subtract 7 from 6. So then we get that minus that equals, and then this is the same, so that drops out, and then we get b times this minus that. From which flows that b equals this. We don't have to calculate, and you can't make mistakes because you use just the mouse all the time. Copy paste. Yay, symbolic stuff. But I did it wrong, I think, because, well, not really wrong, but I should have. Because it would have been easier if this thing was exactly the same as that one. Cucumber squared, we have that here. So the minus sign is wrong. Okay, let's subtract 6 from one thing from the other, which means that we get minus that. So let's just turn it around. Minus that. And here also change the minus sign. That. Minus that one. Let's cheat a little bit. Yup, so in other words, A divided by B is di dot s times s length squared minus talking about this one, di dot s times q gamma squared minus di dot q gamma times s dot q gamma. Okay, so that then is equal to the square of 1 minus gamma divided by gamma. So we can just take the square root, I guess, and then multiply both sides with a gamma and stuff. Double. Now let's work this out. You have to go to bed, yeah. Okay, man, good night. Thanks for hanging out. I'm gonna continue for another hour at least. I just want to have gamma here. Gamma equals, but it's not that easy. So I'm gonna do gamma 1 minus gamma. Lower 5s. You completely lost me again. Good night. That is, that no, not no, nah. Don't do that. It's not interesting. Hanging out is socializing, but I don't think it's well. If you like watching it, then you can do that. But we have this. This is correct. Totally correct, right? So multiply with gamma on both sides. Gamma times. And then move the gamma to the other side. So plus gamma. And this is then gamma is times the square root plus 1. So gamma is 1 divided by the square root of a divided by t plus 1. Gamma is 1 divided by 1 plus the square root of a div b. One person? No. I see 3 persons. I don't know what you're talking about. There is only one Son of God, that's correct. Jesus. Double gamma. It's 1 divided by this 1 plus the square root of a to b. Okay, we have gamma. Ba-bam, ba-bam. But this thing wants me to return gamma, so maybe I should use just gamma here. And I have to do these things here. Update coefficients matrix. I can just copy this, right? M0 and M10 is always P0, and I already have P0. And then I still have to, this is the velocity vector at, so V0. This is then what follows from that. I mean, having these, I can just calculate the acceleration here. Half the acceleration. And then I can set these two, and therefore we can update that one. I think, anyway. I mean, what else can it be, right? It's my go-to sentence when I think it should work, and I wouldn't know why not. But I have to fill in this one. The rest is template. It seems. And that's the velocity vector, yeah, at 0. Okay, how do I calculate that having gamma? Not at all easy. Oh, actually it is. I need Q gamma and Q1. Then we have V0. I'm just looking at my paper. Q gamma is, I have Q gamma, of course I have Q gamma. Q gamma is this. And Q1 is, what is Q1 again? Maybe I could express it the way I did here as well. Let's express V0. Wait a minute. Do I not have VT then expressed in that way? That would even be better. Yeah, we should type it in. Maybe we should type the whole derivation in here, but yeah, no. No. Or maybe I do. Let me think. Okay, I'm gonna just type it in. Let me see. Because the papers will get lost and stuff. Where does this thing begin? This is old. That looks old. Oh, this is actually about the length. So not doing anything about yet. These papers are from yesterday, I think. About length. Just one more paper. Just one. That's not even that much. It's also about the length, damn it. Oh, it's this paper. It was upside down. No, the rest. That cannot be right. I'm making the same mistake I made this afternoon, I think. Huh? What? Q comma equals 0 times gamma plus Q1 times gamma squared minus 0 times gamma squared. So that is times gamma times 1 minus gamma. Q1 gamma squared totally. Which means that 0 is yeah. I made the same mistake. Unbelievable. My brain is wired wrong, apparently. Of course, we just bring this over to the other side. So it is Q gamma minus that divided by this. Yeah, and then there is no need for the negation that I applied here. Yes. And then I had a brilliant idea to write that as a linear, what is this? Linear expression, whatever, of Q1 and Q gamma. So it is 1 divided by this. Times Q gamma. I'm going to put superfluous parentheses around it. All. So that was the Q gamma, and then we have this Q1, right? Is that all? Minus. Now we have gamma squared divided by that, so I can remove one gamma, so I get gamma divided by this. Times Q1. And then we continue with let S is, well, it's defined here already, but it's not even right, man. I made that mistake also again before. What the hell? It's just P1 minus P gamma. Yep. But now I can subtract P0 from both, so that doesn't do anything. And then I have a P1 minus P0 minus Q gamma. And that is my Q1. So maybe we should first define Q1 then. Oh wait, I already have a Q1 here. Seriously? Oh yeah, but that's what it is, of course. Q1 is Q at T is 1, which is P1 minus P0. That's exactly what I wanted. So Q1 is P1 minus P0. Yep. So S is actually, so it's not let, but well, it's a let if you ignore this and start reading here. So okay, I'll just copy that and then I'll rephrase that as P1 minus P0 minus P gamma minus P0, and then we can write that as this is equal to that with T equals 1, which is equal to Q1. So this is equal to Q1 and this is equal to, well, Q gamma. It's Q at gamma. So that is the same thing. P gamma minus P0. Yep. And then we can write V0 equals this whole thing. And I want to get rid of Q1. Well, rather I want to replace Q1 with S. So we have to subtract Q gamma from that. So this that is this factor here. But there's a minus here, so I can start with a plus. That vector times S, and then of course minus that same thing. No, I'm not doing that right at all. I want to move to S, so I need a Q comma, sorry, not S. Yep, and then minus the same thing. You also just added this and then subtracted it again. That doesn't do anything, so that's still correct. But then we can write that as I'm going to combine that with this. So we get that thing. Times Q gamma. And now we subtract this. So I'm going to do minus that. And then times Q gamma. And then this one minus that one, so that's that stays a minus sign, I think. That times S, because S is Q1 minus Q comma. Yep. And that is equal to now this whole thing should be the inverse of that one. Can I still see that? Can simplify this, multiply this with gamma above and below, so we get gamma squared divided by the same thing as here, so gamma times 1 minus gamma. And then we get therefore 1 minus gamma squared divided by that, and 1 minus gamma squared is 1 plus gamma times 1 minus gamma. So that drops out, so we get 1 plus gamma divided by gamma. That's not good. I mean, it's different from what I had, which worked. So I must have made a mistake somewhere. I don't know, man. I just have to start at the top, I'm afraid. Okay, pt is p0 plus v0 times t plus a half times a0 t squared. Definitely correct. Know that p0 is p0. Yep, t is 0, then this whole thing drops out. Let qt, just a new definition, is pt minus p0, so let this one drops out and the rest stays. Definitely correct. Let q1 is q at 1, yeah, duh. Is then we just fill in 1 here, so you get v0 plus a half times a0. This is 1, this is 1, this is q, yep. From which you can conclude that a0 equals q1 minus v0 times 2, correct. From where it follows that qt is now equal to v0 times t plus a half times a0, which is this, so the half drops away against 2 and we are left with q1 minus v0 times t squared, which in turn we can write as v0 times t times 1, that would be that one, and minus v0 t squared, that would be this part, plus q1 times t squared. Pretty sure this is correct. Yep. Okay. Let q gamma is the q at gamma is then v0 times gamma. Oh, wait a minute, I'm here now. v0 times gamma times 1 minus gamma plus q1 times gamma squared. Cannot be wrong. From which follows that v0 equals q gamma minus q1 times gamma squared divided by gamma times 1 minus gamma. Yep. No errors there, right? Which equals 2 just 1 divided by this thing, gamma times 1 minus gamma times q gamma. Yep. Minus gamma squared divided by that. So just gamma divided by 1 minus gamma times q1. Looks really good. Let S be, well, P1 minus P gamma, which is, yeah, which is P1 minus P0 minus P gamma minus P0 is Q1, P1 minus P0 is Q1, huh? Yeah. P1 minus P0. Yep. And P gamma minus P0. That's Q gamma. Thus S is Q1 minus Q gamma. Q1 minus Q gamma. Yep. P0 is, I just copied this and then I added that and subtracted it. So this is the same as I have after that. So now I have so then this should be wrong. So far everything was correct, I think. Also correct, damn it. How the hell is that possible, man? Oh. Yeah, no, it's correct. I was confused with the V gamma. V gamma is a minus sign, but this is V0. Duh. Well, I haven't written down the derivation of V beta yet. Yeah, V gamma. Okay, so no problem then there. They can just simplify this to yeah, so this is 1 minus gamma times 1 plus gamma. So that leaves us with 1 plus gamma divided by gamma. Right, yeah. And then somewhere here I have something about V gamma. So this comes out of nowhere, though which is not nice. Let me arrive that one as well then. So Vt is the derivative of, well, Qt, Pt is Qt, same thing, it's just constant. Which is then V0 plus A0 times T. So V gamma can be written as A0 times gamma. And A0 is not given here. Yeah, here. Of course it is given. Here, this. It also contains a V0. Yep, and I want to get rid of Q1 again, so I have to subtract 2 times gamma times Q gamma to make it Q1 minus Q gamma. And then therefore add it again, which then gives us this times V0. Yeah, that is this factor, that's factor times V0, which is here. So that times Q gamma minus, and then the same factor times that part, whatever. And then I just have this part. So then we need to subtract, now add this Q1, but I'm gonna combine that with this one. So plus this times S, it's Q1 minus Q gamma, that was S. S is that. So this is that part, and now we have to add this again. Which then becomes, and then let's combine the Q gammas together. And the S together. V gamma, this one. Yeah. So Q gamma up front. Times Q gamma S Q gamma plus this. Times Q gamma. Here's my S. This is times S, so this is also S. I'm gonna start with this. So I have a plus to a comma minus that times S. Yeah. Yep. That simplifies like crazy. I don't see it yet, but I know it. It better does that. It better does that, yeah. Let's just make a separate line of that. So. this equals, well, 2 times gamma, there's 1 minus 2 gamma. Because 1 times this minus 2 times gamma times that. Man, this is not easy at all. Okay, let's divide this by gamma. And this by gamma. And then I can delete that part. And then I want to multiply this out. I get 1 divided by gamma. So 1 times this is that. And minus 2 gamma times that. That is minus 2 gamma times this is, gamma drops out, it's just minus 2. And then minus 2 gamma times a plus 1. It's just that. And then plus 2 gamma again. So that drops out. And this drops out. Although that becomes a minus 1. Which we can write as gamma, it can be written as gamma divided by gamma. So we can write the whole thing as 1 minus gamma divided by gamma. And the other one, this one, that becomes gamma divided by 1 minus gamma. But how do we see that? Well, very wide. Let's put it that way. Right. Hopefully it is the case. It's so I hate it when I make a mistake and I have to go back. Can I remove those? I don't see it. I don't see it. This is just multiplied by that, so I don't need this. Parentheses. Good to multiply this with 1 minus gamma and divide it by that. And then here we get minus all that. Oops. all that divided by 1 minus comma. So we can bring it under the thingy. And then what is above here should become gamma. Do you see it? Yeah, let's just multiply it out, I guess. So this is 2 times gamma minus 2 times gamma squared. I'll multiply it out, so this is times 2 gamma. And then this also times 2 gamma. And then this is times gamma, that becomes gamma, and this is gamma squared then. Squared. Then we have minus gamma, but really plus 2 times gamma squared. Which means that the minus 2 gamma squared drops away against a plus 2 gamma squared. And the 2 gamma minus gamma is just gamma. There we are. Just gamma. In other words, this is equal to that times q gamma plus gamma divided by 1 minus gamma times S. S is easy to see, as they would say. Okay, so on this I think I used already down here. Yes, you can see I did. That's the same thing. Okay. Complete derivation, moved from paper to code, comment. What should we do next? Oh yeah, I need to calculate V0. So now I have my formula here. V0 is, well, simply that. Yeah, okay. Boing. And that should be it. That should be it. Okay, step 1. Test if it compiles. cost compiles. And then tab 2, use it. Quadratic from, and then just pass the direction and points, comma, or whatever. Tests, from hacking cubic, Bezier.cxx. Yeah, well, I can just use it. Can just use it right here, right? I mean, V0 direction should be V gamma direction, which I don't have. How the hell do I get a V0 here? I'm just going to rewrite this. Do I get into problems then or not? I don't think so. My only problem is that I have no idea how I get V0 here. Oh, this, yeah, okay, that's my dragging thing. So, forget V0. So instead of 0.0, I'm going to use point gamma. Which means that we should not use V0, but V gamma. Direction, and actually I have no idea how large it is, so I'm just going to use that, call that D gamma from of direction, and then we have to get rid of V0 and not use it. V0, here's the V0, it's probably the V0, definitely. Yep, so I'm just assigning here a random V0 from my plot thing minus P gamma. Plot Q, yeah, duh. So that's going to be direction D gamma. Should work. I don't know why it would not work. I cannot convert vector. Is that explicit? You gotta be kidding me. Considered it, but no, you cannot construct direction from a vector. Dubious. Okay. I have to explicitly ask for the direction. I'm not sure. Maybe I should ask, add the constructor. Now we have to test it. It's scary shit. Crash. What? That's the worst. Oh, assertion false failed. Interesting. Don't tell me I used, no, I used point comma. Never ever ever will we get here with something else than 0.0 and point comma. Oh, I drop out. Drop through. Yep. Okay, so return something. What do we return here? Return true. It's always working. Why would this not work? That's a good question, actually. There must be is there a possibility that it does not work? How would this not work? That's a good question. Well, apart from division by 0, but there'll be a whole area of stuff that doesn't work. The direction can impossibly go in every direction. Oh, negative, of course. If you cannot take the square root of a negative number. So it can do if that is less than 0. Return false. That won't work. The rest should just work. I don't see a BezierCurve at all. Ah, that's the reason. Of course, now it had the velocity in P0 must be in this quadrant, but the velocity in B gamma must be in this quadrant. And it so works, you know. I love it that I can do this without making any mistake. Yeah, great. And then nothing here. Oh, we have something. Oh, that's interesting. Oh yeah, of course, the direction. It's just taking the direction, though. It doesn't care that it is not really the direction, but a negative. This should not work. I mean, it is with direction. I really mean, you know, the direction of the velocity, not that you have to multiply it with a negative number. So this part is also not allowed. How can I detect that one? Detect that it is the opposite. Let's look at the code. I guess in product between not V0. I have to calculate velocity then in B gamma. Do I not have a V gamma calculated? I have a formula for V gamma. So the dot product of V gamma with DI is negative, then it's I should return false as well. I think that is simply the case when gamma is larger than 1 or not. The whole thing is probably negative. Opposite, yeah? Yeah, of course. Either gamma is less than 0 or gamma is larger than 1. That would make it negative, which means that if, well, wait, that's not for me to do here really. Although, well, in this case it is. Damn it. No, it's not true what I say. This is always positive. Cannot be less than 0. Can be larger than 1 though, but I don't really care, and that is not the case. The velocity is the other way. No. I think I have to test the validity then by looking at V gamma calculated. There must be an easy way. If you work it out, it's probably an easy formula. What about this part that dropped away? This part. Yeah, of course, that's it. If A or B is negative, then the dividing it still positive, but the problem is then that there's also a minus sign here though. I'm gonna go over this part here. Damn it, that was not it. Okay, then I just test this one. Yep. Okay, then we do that. At least that's cheap. Can do it in parts. Because the denominator is the same. Now, the thing is, of course, that to get a minimal arc length here, my hunch is that this is the bisector of this angle here. Wouldn't it be nice if you could derive that, actually? But what does it mean that it is the bisector? That would mean that if I shift P0 over this line, that we keep having the minimum. So we just move this like this. Then this is still a minimum. So it's now length is now 14.55, so that should be the minimum. Yep. Well, I can make it that. I just wiggle it a little bit. So the position of P0 and P1 can be moved whatever you want over those lines. And the bisector is just giving you the shortest arc length. Interesting. But I did not mathematically prove it. It's probably a lot of work. Yeah, what shall I do? I guess I can just take the direction of this one and the direction of that one and then add them. Then we have the direction of the bisector. But it involves taking two square roots. Yeah, who cares? I want to think to keep up with what I'm dragging this. I wanted to draw non-stop the minimum arc length, which means I just have to pass the right direction, not drag this, but just make it calculated, which is I'm going to do right now. Okay, quit. The shortest arc length. I have abused cubic Bezier for long enough. This is calculating the curve length. Oh yeah, this stupid thing can only work with P0 and P1 and 0, 0 and 1, 0. Which is unacceptable. I want to be able to drag everything. Let's copy a lot of code from here to there. Yeah. Why the hell does the thing not have an A here? I'm not sure the line has a direction. Yep, it does. A line is created from a point in a direction. Where's my direction then here? Looks like 2 points to me. Let's see, our create line is probably taking 2 points. Right, create line is taking a lot of stuff. And then calling constructor line with it. This is one line, maybe plot line. Nope. Point and direction, confusing. Yeah, okay. Nobody knows anymore how it works. What is a line piece? Because I'm passing 2 points. It's not a line. But I do get back a plot line. I'm pretty sure about that. And that thing has a direction. So this should work. Then adding 2 directions probably gives me another direction. I don't think so. Can I even add directions? Highly unlikely, I would say. No, apparently not. You have to convert the directions back to a vector in order to add them. How do we do that? You convert the direction to no. I'll just have to construct a vector from it. Then I can add them, but then it's still a vector. I don't think I can create a... No, I cannot. So we add that, and then we have to make it a direction again. Dot direction. Or explicitly constructed, which is the same thing. Get these. This is an explicit construction. Curvature. Nope. Ooh. What stuff here? Extract the Bezier. No, that's not the one. Oh, definitely not one. Or maybe it is. No. Definitely need to pull this one. Yeah. Let's print the length and plot it. Calculate and print the length. It's not very useful, but I want to keep this formula. What else am I missing now? Highly confusing. Another while. Oh, this. Yeah, I'm so senile. This is a while loop. The other one's a do while loop. Just ends there. Okay. A little bit of a beep. So what was this stuff doing here? Recalculates stuff which I'm not really interested in anymore, maybe. Plot v gamma. This is speed, okay. Well, no. Yes, nah. Create a point, also not. I think I'm done. To compile, I'm done. obviously not compile. Note how it is always obvious whether it compiles or not. No member named direction. Inline piece. Oh, it's a effing line piece anyway. I thought it was returning a line, but apparently we do have a line piece. A plot line piece. Do I have a plot line? Totally have a plot line piece. Line piece, of course, which is derived from line piece, which has no direction. There's nothing. Nothing. Just 2 points. Might as well add direction to it. Of course. Yeah, well, it's kind of an expensive call, but, well. If you need a direction, then you need a direction, right? Because a direction can be constructed from 2 points. I hope. 1 point. 2 points. Yep, from 2. It's expensive because of the umpteenth square root. Error, incomplete result type direction. Well, it's a line piece. I think I can include direction here. Still doesn't work. Still incomplete. Okay, well, this is expensive anyway, so let's do direction. And then doesn't exist. So annoying. Oh, there's the bloody namespace. Wait, I just need this. Namespace. That should be enough. Oopsies. I meant, of course, the other one that I always need. Include sys.h. To use choosing the explicit is really stupid. stupid of C++, I think. Let's switch all to Rust. I'm just kidding. Error. No matching constructor initialization of const direction. Because it's a vector. Dude, why not? No, this copy constructor. Copy constructor. Oh. Move construct conversion from vector to double. Yeah, at least we now know that it is a vector. From vector to point, it just can't construct a direction from a vector. Okay, yeah, I knew it. I'm this close to adding it. I just keep running into it. So I just add it. Let's go ahead and add it. Implicit conversion from vector to direction. Throws away stuff, you know. No, I'm not doing it. Plus is an expensive wall. Now what? Redefinition of plot BezierCurve. Oh right. That's old code. This can be removed. Length, I can do that one, I suppose. Don't need that. I don't know why that is here even. And then that one, we can do this. Yeah, I want to keep that, right? Minimize the arc length. Huh? What? It's already minimized. Stuff. Draw a label for P beta. Yeah, probably. Don't have a Q. Go away. Velocity vector at B0. No. Velocity at B0. What the? Why would I even care? Velocity vector at P beta. Okay, let's draw that one. Angle. Nah. Door V, the parallel vertex. Yeah, that would be nice. Except that. Oh, okay. Yeah. Okay, I think now we're getting there. Or not. Found is not found. Yeah, anyway. Error. Use one declared identifier plot P beta. Did you mean plot P gamma? Wow. Compiler got smart. Beta is gamma these days. Where do I find my comma? Comma. There's no gamma here. There's no gamma inside. Damn it. Gamma, short start length. Gamma. No, there's a comma. The things you have to do. Oh, here's a comma as well. Will it finally compile? No. Redefinition of P gamma label. Oh, sure, I copied it. Maybe, no. Really? Impossible. Pretty sure it still exists inside that file. No. No, I have no idea. What was the error? Error is that it doesn't know what gamma is, or no? It's worse, right? Cannot initialize a parameter of type double with an L value of type double. Double. No except true. Gamma is a function. This is my gamma. Yeah. Yeah. Everything stops working. Oh, I signed that maybe. I don't know, man. The feeling there's still more. Yes, should have said that earlier. Maybe there's a crash or something. You see, I learn quick. No crash. Oops. Why am I dragging? Oh, fuck this. I'm running the wrong thing. Okay, shortest arc length. Bloop. Crash. No crash. So now this should be the shortest arc, but well, we don't know if that is really the case, of course. But it's continuously updating it to be the shortest arc, which is pretty impressive. So yeah, this is correct. The shortest line through these 3 points, which are on one line, is a line. Also, if the vertex here is inside the p gamma, which is because, well, this distance is the same as that distance. So let's put them at the x-axis here. Plus -8 and +8. And then obviously if I put this thing here, then the vertex is exactly inside of it. And the velocity is horizontal. No, it's just a parabola like that. So now move the element there, and the vertex like, vertex goes, and then the vertex comes back, and then it's again, wow, cool. You can even draw one where the vertex is as far away as possible from it. No, I mean giving 3 points. This is the best curve that you can draw. Well, at least the best parabola. Completely agree with it as well, because I wrote the code. Yeah. I'm happy with this, man. Pretty cool. It's also interesting, if you move this up and down, then the direction doesn't change. The tangent doesn't change. But this curve is still influenced. What? Yeah, because if you do this, it thinks, well, then I might as well become a straight line. And if you go all the way there, for some reason it has to become longer as well. It has to become longer. It must be a parabola. So if it would go like this, like this, then you have a sharp turn here, and then we go back like this. So that's not possible. That's what he... Oh, holy moly! He crashed. I moved the point inside the other point. Not a number for a direction. There is no direction between 2 points when they are the same point. Should not drag that like that, I guess. And it's fast. Fast enough. I think I'm gonna go to bed. It's like completely finished, you know. Look at the title: shortest arc length of a quadratic Bezier. Yeah, no, there it is. Can't get any shorter than this. Cool. Peoples, good night. I'll be back tomorrow, and then I'll do something else. What? Can't go to bed without knowing what I'll do tomorrow, right? This is going to be part of my curve function in the case I have just 3 points. Someone asks to draw a curve through 3 points, and this is going to be it. If someone gives you 2 points, I mean, then you're going to draw a straight line. But someone gives 3 points, then why not draw a parabola? Any reason not to draw a parabola is, of course, there is, because this doesn't take into account the bending energy, only the stretching energy. The shortest arc is not always the best. Like, well, I would do it like, let's say, okay, let's put these two close to each other. So we would do this, then, and yeah, I don't know, something like this. Now a lot of energy goes into this bending point here because it's super bending here, bendishing. No, it's not a good word, bendishing. It's a sharp kink anyway, so it almost breaks here. Well, that means if this was made of metal and you almost break it, then the strain here is super large. Suppose you don't want that. Then, of course, it could be better to draw a curve like this. So all the way around and then through the wall. Hey, a circle. This circle is way longer, but at least then I think the bending energy is minimized. Could be. But that's not a problem. But okay, and nobody. Oh God, there it goes again. Nobody said that it had to be a problem. Absolutely not. You just get 3 points. You can draw what you want. So yeah. But when it is a quadratic Bezier, which is a rotated parabola, then this is the shortest arc length possible. That goes through all 3 points. So that's correct anyway. Yeah, not necessarily the best thing to do. I think it's pretty damn close. Pretty damn close. This is pretty much the best thing to do. Maybe not, you know, you do like this, and maybe not. But it's just a ridiculous placement of points. Don't do that. The thing should not be so far away. It should be like super close to the line. So you have a point here. Oh, come on, man. If you have a point here and a point here, it is not a straight line, then at least it's going to be something that looks like a straight line. So something like that. And then I'm totally happy with this curve. Especially since I'm not living 100,000 years. I have to probably move on from this. Starting with going to bed.